Suppose we wanted to find the greatest common divisor, also known as the highest common factor, of 24 and 72. Now, as the numbers get bigger, it gets harder to write out all their factors, starting with the first pair and writing out all the pairs. We can still do it that way, but there are a couple of other ways that we can use to work out the GCD. One way is to use the factor tree. So I can say that 24 is 6 times 4. 6 is 2 times 3. And 4 is 2 times 2. And so 24 is equal to 2 times 2 times 2 times 3. That's it written as a product of prime factors. Let's do the same for 72. 72, and again, it doesn't matter what pair of factors you choose. I'm going to choose 8 times 9. And 8 is 4 times 2, and 9 is 3 times 3. What I'll do, I'll circle the primes to make it really clear that they're primes, and that's why I've stopped. So 2 is prime and 3 is prime. 4 is not. I can still factorize 4 into 2 primes, which are 2 and 2. So 72 is equal to 2 times 2 times 2 times 3 times 3. Now, if I want to find the greatest common divisor, or the highest common factor of these two numbers, what I do is I go and find all the common prime factors. So they both have a 2 in common. I use different colors so you can see how they're pairing up. And they both have another 2 in common. And they both have a third 2 in common. And they both have a 3 in common. But this last 3 of 72, it doesn't have a friend in 24. So it's not a common factor. And so the highest common factor is just the product of all the circled common prime factors. So GCD is going to be equal to 2 times 2 times 2 times 3, which is 2, 4, 8 times 3 is 24. What if we now wanted to find the greatest common divisor of 60 and 72? So let's leave 72 up because we've already calculated it. But let's work out the factor tree for 60. So 60 is 10 times 6. 10 is 2 times 5. And 6 is 2 times 3. So 60 is equal to 2 times 2 times 3 times 5. You don't have to write them in ascending order like that, but I prefer to. Okay, so now we go and look for the common factors. We have a common 2. We have another common 2. We have a 3 in common. And that's all we have in common because there's a 5 in the 60, but there's no 5 in 72. And there's an uncircled 2 left in 72, but there's no spare 2s left in 60, and same for the 3. So our common prime factors are 2 and 2 and 3. Therefore, we can say that the GCD of 60 and 72 is 2 times 2 times 3, which is 12. You need to think about why multiplying the prime factors that are in both of the numbers gives us the greatest common divisor. You need to think about that. And what we can do is we can go back to his first example and do it here and see that we get the same thing. So 16 is 4 times 4, which is 2 times 2 times 2 times 2, and they're all prime. 24 is 3 times 8. 3 is prime. 8 is 4 times 2. 2 is prime. And 4 is 2 times 2. So we have that 16 is 2 times 2 times 2 times 2. And 24 is 2 times 2 times 2 times 3. And so the common factors, the common prime factors are 2, 3 times. They've both got 3 2's in them and they don't share any other factors. And so our GCD is 2 times 2 times 2, which is 8.